Okay, let's see. We're here at ATL BitLab right now. Hopefully we don't have any audio issues. Hey, looks like we have Dan in the chat here. Good afternoon to you too. We had some audio issues on the last stream, so hopefully we don't have that today, but if anybody could, who's listening to this could just let us know if you're having problems hearing, that would be wonderful. And I'm actually going to type that out in case anybody didn't hear me. Audio is great. Awesome. Thanks so much. All right. Well, then we're going to kick things off here. I'm Stephen DeLorme. I run ATL BitLab here. This is a Freedom Tech community space in Atlanta, Georgia, where people come to discuss, learn about, and work on stuff like Bitcoin and privacy technology, AI, all kinds of good stuff. So this is another entry in our Battle of the Mind Hackers series. So this is a global hackathon that we are running out of the lab here. So you can participate from anywhere in the world, hence the live stream. The best way to get involved right now is to just join the Discord, and that's because that's where the other builders are hanging out. That's where the mentors are hanging out. And it's a great place to get help with your projects and share what you're working on. I want to thank some of our sponsors before we go any further. CleanSpark, Pleb Lab, HashLeague, Choya Inc., and CryoBike. Choya Inc. actually plays a huge role in what we're working on today because they generously donated a lot of Antminer S9s to this project that they no longer needed, but we can use for educational purposes for stuff like today. So if you're just coming into this hackathon project, you have until July 1st to submit your projects. We have a software track, we have a hardware track, and we also have an energy track. And so there's a prize for each of those. It's the same for each one, 1.5 million sats, a year of an ATL BitLab social pass, and then also a CryoBite S19J Pro cooling kit. And then also there is a sponsor challenge for HashLeague for the best contribution to the HashLeague. That's a community mining pool dashboard. So we actually had a stream yesterday that Maru and myself did where we talked about the HashLeague project and how to get started with that. There's, I think, 2 project ideas out there. One is to add Stratum v2 support to HashLeague, and there's another one that Eric is spearheading in the Discord. And if you want to help him with his project, I'm sure he'd love to get some help with it. So yeah, you can find our judges, our mentors here. Here's the whole schedule of events. We're running up kind of towards the end of our mentor series. This is today, the Builder Jam session, Bitmain S9 tinkering. We're going to have Gabriel from Stratum v2 speaking to us next week, and then we'll have some more weekend jam sessions as well. Cool. Well, with that being said, I think I'll just take us into today's content. Unless, hold on one second. Apparently I have to like prove my identity with, something here. I don't really know what's going on. Let me debug, how to use a computer right quick here. Sure. Now I'm used to just dropping in like Figma links and sending them to people. And they just work when you open them in the web browser, which is super convenient because then I can have a presentation, but I can also pull up other websites, but I guess I have to be logged in for that to work. Okay. Now I can press a play button and present this. See, I don't want to go back to Figma. I want to that was the problem, is that I didn't share the presentation link. All right. Glad I got that figured out. That was a user error on my part. Okay, cool. Let me share my screen again. Present, share screen, window. And there we go. Let me get it configured the way I like it. All right, so let's get into today's content. Does anybody think I missed anything? Jesse, Mara, did I miss anything? All right, cool. Let's go into it. So we're going to be talking today about the Antminer S9, and we're going to learn several things today. The first, we're just kind of get into like what an ASIC is, just generally speaking, broadly speaking, how we got here and what they're used for. Then we're going to dive a little bit into the Bitmain Antminer S9 and like what kind of makes it a little unique. We're going to show you how to set one up and start using it. We're going to teach you a little bit about how they work on the inside, and then how to diagnose some basic issues here. This is definitely a beginner's crash course, and There's probably far more detailed repair manuals and all that kind of stuff, on the internet. But hopefully this will just kind of, give you the confidence you need to actually start working with one of these machines and kind of empower you to tinker with it a little bit. So what actually is an ASIC? So it's helpful, I think, to kind of go back to the early days of Bitcoin and kind of how that started. In the early days of Bitcoin, you might, download the Bitcoin software and run it. And a lot of people were just mining on their home computer. I think there's a story of I think it might have been Jeremy Rubin mining Bitcoin on his laptop at MIT or something like that in his dorm room. Pretty sure that's a public story. You hear a lot of stories of people mining 50 Bitcoin on just a laptop. That's because there were not many people on the Bitcoin network, and so mining was not a very competitive thing. You could do that with a CPU. Then people started mining with GPUs. Those are graphics processing units. Same kind of circuitry that you would use to play a video game or render 3D graphics if you're like an artist. That circuitry was designed with graphics and rendering applications in mind. So the circuitry is less general than a CPU. But it's kind of a weird quirk of that. People have discovered over the years that you can use that same circuitry for a lot of other things. So you can use it for training machine learning models. You can use it for doing protein folding simulations. And you can also do it for SHA-256 hashing to mine Bitcoin and other cryptocurrencies. So people start mining with GPUs, and that kind of ups the difficulty, right? More hash rate enters the network. By hash rate, we mean number of hashes per second. And this ups the difficulty of mining. And as a result, you had to start using GPUs to be competitive. So then the next kind of innovation are the ASICs for Bitcoin are invented. And it's a funny word, but it means application-specific integrated circuitry. So integrated circuit, that's like a bunch of circuitry on a chip. So it means we're making this integrated circuitry chip that is designed with one specific application in mind. Like we want it to do one thing, and we want it to do it really, really well and really, really fast. So there's actually ASICs for all manner of things. But when we talk about ASICs in today's presentation, we're really talking about ASICs that are meant specifically for Bitcoin mining. And so ASICs for Bitcoin were invented. There's been R&D on those over the past 16 years. They've gotten way, way faster, and we're now at the point where you can really only mine competitively if you're using an ASIC chip. Today that's the situation we're in. I think there's pros and cons maybe worth highlighting, and this might be some, worth discussing later. But, on the one hand, I think they're really, really great to mine profitably. And I think that kind of like if you think of Bitcoin as like being a decentralized currency, we obviously want a lot of people mining. We want like a good security budget invested in securing the network and keeping it decentralized. And so if you want people mining, you want them to be able to mine profitably, or else they're not just going to do it benevolently. So I think ASICs are really, really good for, helping, like rational economic actors mine profitably. On the flip side of that, it is harder for new entrants to enter the mining space. I think it's because we have CPUs and GPUs. Just those are so common. You find them in your laptop, you find them in your phone. It's pretty easy for everybody to start doing other types of computing, more general types of computing. But for Bitcoin mining, you need an ASIC, and ASICs are just not as spread. Bitcoin ASICs are just not spread as far across the earth. So it's harder for new entrants, and there's not enough companies making this hardware, as we've kind of discussed in other of the mentor presentations. So that's kind of where we're at. There's pros and cons, but the situation right now is that if you want to mine profitably, you need ASICs. So let's get into the Bitmain Antminer S9. So I have a nice visual up on screen that's probably easier for everyone in the live stream to see, but we have a lot of Antminer S9s in front of us. We have some on the table right there. Let's get into what this does. So this is actually an older miner. This was released kind of mid-2016. This is manufactured by Bitmain, which is like the largest, mining hardware manufacturer in the world. The hash rate, they say it's like somewhere between 11.5 to 14 terahash. That's with the SHA-256 algorithm. Typically, you get around 13 terahash on average. Draws about 1.1 to 1.4 watts on the wall. and the efficiency is 0.098 joules per gigahash. So that's a awkward sounding number. Did you
read 1.1 watt kilowatt, right?
Yeah. Yeah, I mean, sorry, I meant 1.1. I was reading sorry, on my screen it says 1,100 watts, but I think I might have was trying to say 1.1 kilowatts. And the efficiency thing is something kind of interesting. Well, maybe we'll get back to that in a second. And then the chip configuration, it's got 3 hash boards inside. It actually has 189 ASIC chips inside of it. And we'll kind of revisit that later a little bit more. But this is kind of known in the Bitcoin mining space as being a very friendly ASIC for beginners. So this was cutting edge tech in 2016, but it's so old now that you can actually get these things for super cheap. Because it's super cheap, if you're just getting into mining and just learning it, it makes it a really cost efficient, accessible miner to get. It uses typical like 120 volt power. That means you can plug this into a standard outlet. In a US house, that means you don't have to play home electrician just to get into mining. You can plug it into a wall you already have. And it basically just works when you turn it on. I mean, you could do this as part of a larger mining operation, but it also works just fine if you just want to plug one in and start, working with it. So I think on that note, in terms of like why they're super cheap now, this would be a good, place to touch back on the power consumption and the efficiency. So a lot of times when you're looking at miners, you'll see these things measured in terms of joule per terahash or joule per gigahash or whatever measurement. But how many joules per how many hashes I can get out of it? The reason for that is because like when you start thinking about like how a miner is going to mine profitably, one factor in that is where are you getting your energy from? Where are you located in the world? What energy sources are you using? How much does it cost in that area? What is the local energy market like, right? So you are kind of constrained by those energy costs, but completely independent of the energy costs you pay, you can also focus on efficiency. And that's really, the efficiency is really a function of the hardware you're using. Is like, for a given joule of energy, like how many hashes can it do? And some mining equipment can do more hashes per joule than others can. And so like the newer mining stuff that Bitmain and other manufacturers put out just simply, has a better ratio than this model does. So you're not going to be the most profitable miner just, unless you have the cheapest energy in the world that just nobody else knows about. You're just not running as efficiently as other types of hardware. So I think a good way to think about these sorts of things is, one, it's a good way to learn mining. It's a way to learn mining without an upfront cost. And another thing is perhaps you can repurpose these things for heat reuse. So there's a lot of this hardware that you can get very cheaply. And remember, one of the tracks for this hackathon is an energy track. So what if you took, if you were able to repurpose some of this hardware and reuse the heat for other stuff? And it's maybe not making you as much Bitcoin as the next miner, but it is, kind of reducing your power bill in a certain sense, and that like you're kind of getting compensated back in Bitcoin. So these are things to think about. Let's get into setting up an Antminer S9. Okay, this is where we're going to break from the slide format a little bit, and things are going to get a little weird here. The first thing we're going to have to do is plug a miner in. So let's do that. Maybe we should plug in one of the ones that we know works. I'm kind of thinking we just go like full detached camera mode here and just take the camera with us. Here, I'm going to go back and okay, so you're probably not going to hear us very well as we're doing this because I'm going to have to leave the microphone, but I'm just going to take the camera upstairs and we're going to go plug in a miner, and then we're going to come back down and we're going to resume the stream. Okay, so this is the one we have 3D function dashboards. Yeah. Oh yeah? There we go. Just that. I hope that shot was worth it because it took a long time to set up. Okay, we're back with our camera the way it's supposed to be. And I'm actually gonna, let's see, I think I can do it with the same screen I already have shared. Okay, so actually no, I'm gonna need to share some more screen. Let's just share the whole thing. Okay, so we plugged in our miner. You may have noticed we went upstairs. We plugged in an Ethernet cord and we plugged in a power cord. So what we're going to do now is we're going to run Angry IP Scanner, and we're just going to scan some other devices on our network. So this is just a thing. It scans your local network for devices that are running live on the network with the ports open, and we're just going to run this until we see an IP address that we don't recognize. I wonder if everybody in the stream can hear everything. The miners upstairs. It's like the noise is pretty overwhelming.
Yeah.
I'm pretty sure it's this 41. So I guess I should give a little tour here too. So what I did is I sorted this by port to show only the ones with open ports. And just as a web developer, I know that anything with port 80 open, it's like running a website. And I know some of these other IP addresses are on my network, so I'm assuming this new one that popped up is the miner. Yep, there we go. All right. So we have found the website for our miner. I think there's different types of operating systems that you can install in your miner. This one's running Brains OS. So if you do a factory reset on it, which on the back of the miner, there's a little place where you can put a pen into it. And you hold the pen in for 5 seconds, until you hear it click. You hold that for 5 seconds and then pull it out. And the miner, you'll hear the fans whirring and it'll restart. And when it restarts, it'll be back to factory, default factory settings. So if you do that, it should be root for the password. So we're logged in now. And this is a seemingly healthy miner. We can see on here that it has 3 hash boards, and each hash board is running at pretty close to 4 terahash per second. So remember how we said on average we get about 13 terahash per second? There we go. We got pretty close to 13 right there. So this one's looking good. So one of the first things you're going to do with your miner is update the pool settings. I mean, I guess you could try to lottery mine, but you're going to have a better advantage in a pool. You can also run your own mining pool too, right? So what I'm going to do is go to miner and then configuration, and you can set up different pool groups. And I think the idea with having the multiple pools is that basically if one of these things fails, you have another pool that you can go to. So typically Stratum v1 is what most mining pools use these days. So you do Stratum plus TCP. Let me blow that up so you can see it a little bigger. Stratum plus TCP : pool.atlbitlab.com:3333. And 3333 is kind of the default port for Stratum v1. Whatever mining pool you join could use a different port, but that's the default. And so this is the ATL hash force pool. So if you want to point your hash rate here and help us defeat Austin, that would be much appreciated. But then you have to put in a username and a password. And so the Stratum protocol actually supports a user and a password. But a lot of times the password field isn't really used for much. I think in the early days it was meant to be used for something. But to my understanding, a lot of different pools will use it for different things. So a lot of pools these days just ignore the field altogether. Public pool just uses X. And then other types of pools will sometimes allow you to put other types of metadata inside of the password field. But it's not really used actually in an authentication context as far as I can tell. So what's really important is the username, however. Username, and what you do is it's in 2 chunks. So there's the first part of the username, and then there is the worker name. And so not every pool, but a lot of pool will just ask you to put a Bitcoin address as the username. So whoops, we doxed a Bitcoin address. But yeah, so a lot of pools will just want you to put the Bitcoin address at the front, and then you put a worker name at the end. And this is kind of arbitrary. Like, there's not really a wrong value for this field. You put, whatever you want the name of the worker to be. But I've dubbed this particular S9 as ATL Hashforce 09. That's the worker name. And that way, if, let's say, this miner starts bugging out and submitting invalid shares or doing something wrong, the pool can report that and say, hey, worker, ATL Hashforce 09 is, bugging out and doing something wrong. So that worker name actually helps you identify which miner in your kind of fleet is not behaving properly. So yeah, we put in pool.atl BitLab. We have some backup pools here. And once you've entered your pool, you can hit save and apply. And then, we can hear the miner upstairs. It's like, it kind of resets itself and the fans go haywire for a second. So that's pretty much the basic gist. I mean, this thing is running, and as long as you can tolerate the noise or put it somewhere that's sound dampened, you just let it sit there and mine and do its thing. Cool. Maybe before we get into that, does anybody have any questions just on the setting up of the pool interface? Anybody? Here's Dan in the chat. Yep, can hear that bad boy ramping up and down. All right, let's go back here. Let me. I'm done using the. I'm done sharing the IP address stuff, so I'm just going to go back and share just my browser now. All right, so we've done the basic setup on the Antminer S9. Now let's talk a little bit about how it works on the inside. So I actually have, this is where we're going to actually just want to go full camera here. Let me see if I can take the mic with me. Hey, we can. It works. Amazing. All right. So here is what we were just working with upstairs. So this is a Bitmain Antminer S9. Typically comes like this. Mario went and broke down one of these. Thank you so much. Let's get into what we have on the inside here. So maybe let's just start from as electricity goes through it. So very first part you have is the power supply. This is what gets plugged into the wall right here. Your power goes on here. This is going to, convert it from AC to direct, all that. On your power supply, there's 3 cables, well, actually 4 of them, that come out, and you're going to power the different components that are inside of this thing. So the first thing, this cable right here is going to go power the control board. And you can kind of see it's exposed here on the top of the miner. And this one is already pulled out right here for you to see. So the power goes right in there. And this is, just think of this as the computer that controls the whole miner. You also have a network interface right there where you plug in your Ethernet cable, some lights and all that. And this is what controls it all. From there, there's actually 3 plugs that actually go to 3 hash boards. And so you'll see these ribbon cables on here that actually connect and go back down into the unit. And that's because inside of this thing are the 3 hash boards. So you can kind of see it opened up like this. And the 3 hash boards can slide in and out. These are those ribbon cables I was talking about. And then this is an example of one of the hash boards right here. I might want to pull this up closer to the camera later for people to see, but I mean, you can probably Google this, but it basically looks like a green printed circuit board, and each one of these little silver things on it is a heat sink, and underneath that is an ASIC chip. So when we talked about them having 189 ASIC chips, that's 189 chips that are divided across 3 boards, and each board has multiple chips on either side of it. So yeah, each one of these is performing SHA-256 hashes and all of that. And then you have the fans. That's kind of the other major parts. You have one fan on each side of it, and those go on the side like that. One fan sucks air in, the other fan blows air out. And if you're not familiar, I mean, if you've built a gaming computer before, you're probably already familiar with this. But if you haven't, the basic idea is you're pulling in air, and these heat sinks, the metal of the heat sink is pulling the heat away from the ASIC chip, and then the air that's coming in is kind of blowing, is kind of taking some of the heat off of those heat sinks and out the back of the unit. So that's the basic gist of how this works inside. And I should go ahead and point out that this is really the most important part of your mining equipment right here. And this isn't just for the Antminer S9. This is for any kind of mining equipment that you can get, even if it's a newer model. The most important technology is the ASIC chips, these tiny little things that are underneath these heat sinks here. These are the things that are very difficult to produce, and there's not many companies that do produce these things. These are the things that give the miner their hardcore efficiency gains. Whereas the control board, this is just basically any other computer. If I remember correctly, from a couple of days ago, I think Scott was telling us about on his live stream that he or somebody else had worked on a project to use a Raspberry Pi as a replacement for one of these control boards. So there's a lot of options. This I think, from a hacker's mindset, could be a replaceable part. But this is the real high-tech stuff here that is kind of difficult at this point in time to do in an open source context.
I remember when I was doing Ethereum, even the CPU, it was GPUs and CPU, the CPU was the AMD Sempron, which is the most basic, cheapest one. You just needed it. You just needed it to tell. Yeah. Basically, it's you just need the simplest, not very smart. Yeah. Yeah, exactly. I'm not sure if anybody in the stream could hear, but somebody in the audience was just relating mining Ethereum and how you'd use an AMD Sempron, super basic, cheap chip. You just need something to tell the hash boards or the GPUs what to do. So yeah, and some of these are, these are actually pretty clean looking. I'm surprised. There's some dust kind of caked on there that we kind of want to get off, but it just depends on when you get one of these things used. That's going to depend on what condition, where it was run is going to depend on what condition that it's been in. And so if this was running in a perfectly clean environment, with great airflow, like a proper data center, then it might look really clean on the inside, but if it was running in somebody's house, there's probably going to be dog hair and cat hair inside of it. If somebody was running it in a warehouse in Central Texas, there might be pollen and dirt and stuff caked in there. So it really just depends. I mean, miners go all over the world, and people will put these anywhere from a data center to a bedroom to a hut in the middle of Africa, and so it varies so wildly. Cool. You guys think there's anything else? Yeah. What's up?
So maybe you could say it, the fan direction.
Oh yeah, fan direction. Yeah, Jesse wanted to point out the fan direction. Yeah, if you're not familiar with setting up computers, always make sure you get your fan direction right, especially if you're going to try and tinker with one of these things. If you take this thing off, you put the fan back on, you got to make sure that fan's pointing in the right direction. So you want one of them blowing in, and you want the other one blowing out. So if you don't feel, if it feels like it's blowing out on both sides, you've done it wrong. If it feels like it's not blowing out on either side, you've done it wrong. So get your fan direction right. Yeah.
Steven, aren't those the chips I can put on a BitX?
No, these are not. Question, Steven, aren't those the chips I can put on a BitX? Close, but not quite. So yes, the BitX project does use ASIC chips that are pulled out of Bitmain mining computers. However, those use the S19, I believe, which are the much newer model. So you can imagine, though, if somebody wanted to build a BitX, you would have to take something that looks kind of like this, but it would be the newer model, and you'd pull out the hash boards, and you'd have to manually disassemble all these chips and put them on BitXs. But it's a different model. But maybe if somebody wanted to print a circuit board or something like that was compatible with these, then we could turn these into tons of tiny little miners. All right, cool. Let's move on. Let me take my microphone with me.
All right, let me just check the chat. Everybody doing good in there? All right. Then I'm going to bring this back up on stage. Thanks for the camera assistance there. Okay, so we talked about how it works on the inside. We'll go over some basic troubleshooting here. As always, I'm not an expert. I'm kind of learning about mining in public with all of the other hackers here. I'm not an expert on cleaning or repair these things, but I've built and repaired a bunch of regular computers in my life. So I think if you're familiar with working on a gaming rig or building a video editing workstation or anything like that, it's the same basic principles. One thing that's kind of like specific to working with these that we've kind of learned is they all have let me pull back to here. They have this light here, these two lights here that you can see from the front of it, and there's normal and fault. And one thing we very quickly learned is that if you plug in the power to one of these things and this thing has a solid red fault light, you will never find that thing's IP address on your network. So that's one of those things that's something is seriously wrong inside of it, and I don't think that thing is going to mine. Now, what that would be, is that a control board failure, or is that just a triple hash board failure? I'm not sure, but I would think it might be some kind of control board failure because like I said, we never even find its IP address on the network if you have a solid red fault light. If the fault light's blinking, usually means that the thing will mine, but there's some kind of problem. So for example, we have some of the ones that we got donated that might have one hash board or two hash boards working. The other ones will be broken. And so some of those, it will have a blinking red fault light. So something's wrong with it, but it'll still mine. It's just not, working like it should be for factory settings. Some of the other ones we've plugged in, it'll be the power supply will, kind of kick in, the fan will whir a little bit, and but then the rest of the unit with the hash boards will not power on. And so I think from there, it could be some kind of power supply failure, but that could also indicate a control board failure, I think. So yeah, it's a wide world, but I think of it very similar to the way I would approach just kind of fixing a gaming PC or something like that, testing the components one by one. For example, one experiment that I want to run later with some of the units we have here, there's one that I suspect is a broken power supply. So we can test that by swapping one of the power supplies from the miner we have that's working and seeing if that fixes the problem. And if that doesn't fix the problem, then we know it has nothing to do with the power supply. Then we could try maybe swapping control boards or something like that. So there's a lot of different options. Also, when you're getting these used things, I think it's worth it to just go through and, like with the ones I have on the desk right here, just inspect every cable and just see if there's obvious, cases where stuff is shorted out. Like if you find some singed black looking area on the device where maybe, another piece of electrical, metal contacted it and it short circuited it, or something got too hot and the plastic casing around the wire melted. These things get pretty hot. And so that's kind of a thing. So I think that's all I have to say on troubleshooting. Does anybody else have any other comments on troubleshooting and all that kind of stuff?
I mean, one thing to point out is the power supply is 12-volt output, so you've got the multimeter, pretty easy to check it. It's getting local count. There's 4 lugs. What I've seen is there's a bridge though, so you should either have power, right power on the lug or nothing at all. If you're thinking of power installation, that'll be probably a great test. But also test the under load while it's running, because that is a good whole big amount of energy.
Got it. Yeah, Jesse was, giving some electrical insight there, and also mentioned that if you have a voltmeter or something at home, because this works with your standard, home power outlet, you can just use the same voltmeter you would use for working with other electrical stuff around your house to test this power supply. If you want to go further. Cool. Well, I think we're kind of at the end of the presentation, so I'd like to go ahead and just riff on some kind of project ideas for the hackers. like I said, this is an older model, and I think the way to think about this is if you just want to learn mining, this is a great tool to use. We have them available for you at ATL BitLab here if you would like one. Because they're so inefficient, I don't know that you would really use this as like a daily driver, but like if you did want to experiment with, can I use a different control board for this? I think that would be a great project, is to just think about like, how do I replace the control board with something where I have full control over the firmware that's on it, how it's running. Another project idea would just be think about like, how do you overclock something like this to get as much efficiency as you can out of it? Because, I mentioned the fans as part of, how it works, what's on the inside of it. But really what we really mean is just more broadly the cooling system. So if you buy one of these things, the cooling system that comes with it by default are 2 big fans. You could set up another cooling system for this. You could set up a liquid cooling system, kind of like you would like liquid cooling on a gaming PC. If you wanted to, people would do like immersion cooling and stuff like that. So you can think of a cooling system. You could, find a way to overclock one of these and get more efficiency out of it. Another thing, on that note is just the heat reuse aspect. If you think about the cooling system more broadly as how do I just get the heat away from the chips and towards doing something useful for me, you could build, we got one guy in our community who's working on a hot tub, like a Bitcoin mining hot tub. This would be, I think, a great piece of equipment for that, especially to prove out the concept. If you attended Rav Hodl's talk the other day about how to put your miners to work around your house and reuse the heat for all kinds of stuff like water heater, sous vide cooker, maple syrup heater, all of that. If you think about it from that context, this is a super cheap way to get started with that. You don't have to invest a lot of money to get one of these. Like I said, we'll give you one for free. And then you can just start using the heat from this miner and finding clever ways to reuse that. So there's 17 more days left in the hackathon to build. Let us know, if you need help with anything in the Discord. Let us know if you need a miner. All we ask is you pay for shipping. But we're happy to send you one of these if it'll help you with your project. Yeah, cool. Well, I'll just open it up now. Are there any in the room here or in the online audience? Do we have any questions or comments on this topic? I'll give it a second to see if anybody in the chat has anything. Otherwise, we'll go ahead and wrap it up.
Stats for this one miner. I just want to see how it's.
Yeah, like the overview page. Mm-hmm. Yeah.
So 12, 11, yeah. And it varies throughout the day, right?
Yeah. I mean, yeah, depending on how efficiently it's running at 89 degrees Celsius. Oh, that's fucking hot.
Yeah.
Yeah, and there's not that much heat coming out of it, so we're probably a little dirty. The defense fire or probably a little fly out of the fucking bull heat sinks.
Yeah. Okay. Yeah. Jesse thinks it's clogged up on the inside, so we need to bust that thing open and see if there's anything that's grimy on the heat sinks.
One of the boards it looks like is down.
Oh yeah, board number 6. It was kind of interesting. We were looking at it earlier, and you can really see exactly where the power supply cables go into the top of the 3 cables go down into the top of the miner, and each one has a little bit of a light on it. So I'm kind of curious to know if that light changes color if one of the hash boards isn't working, or if that light fails to come on or something like that. Because that'd be an easy way, if that is the case, it would be a really easy way to diagnose the
which one needs to be.
Yeah.
I've seen a bunch where the light doesn't come on. It's not in good shape. I'm not aware of changing color.
Well, that would be just as useful, even if it's not a color change. If it just doesn't come on, then that would be.
Look, I bet board 6 is lights on.
Oh well, no, it's running, Jesse. It's running. It's just running less efficiently.
Oh, okay.
So, but
Okay,
there,
good.
yeah.
Already stood up.
Is Slush Pool Bitmain? I recognize that.
Slush Pool
There's
is,
just, no, it's just enough, it's like one of the biggest.
yeah, and I think it's with Brains, the company Brains. I'm pretty sure Slush Pool is,
I recognize that. There's Ant Pool too.
yes.
Okay.
Yeah, there's Ample, and so Brains and Slush Pool are related. I think Brains is just the name of the company, and it's also the name that they give to their like miner firmware and pool software and all that. And then Slush Pool is the actual like pool that they run. Yeah. I think that's why by default, when I did the factory reset on all of this, the
That's how I saw it, yeah.
yeah, all defaults to Slush Pool.
Yeah, okay.
It feels like a nice little hair dryer behind it.
Nice.
Yeah, exactly.
But not 200 degrees.
All right, cool. Oh, here we go. Question. Can we build a miner using Android phones? I don't see why you couldn't. I just don't know that it would be like the most efficient thing. And I think it just depends on what you mean by building a miner using an Android phone. So if you mean doing something like just taking an Android phone, any old Android phone that you would get at a phone store, and like writing some kind of application on it to, mine Bitcoin. I don't think it would be super efficient. The circuitry in it wouldn't be great at hashing. So I think it would just drain your phone's battery and not really, do a whole lot. Having said that, if you wanted to do something like, well, can I take the hardware from an old phone and repurpose it to use it as a control board? Yeah, sure, anything's possible. With enough elbow grease and hacker mentality, you could probably put build an operating system that runs as an Android application, and probably do something like that. I would think. Good question. And let me just double check the Discord one more time, see if there's any chatter in there. Fire emojis, but not questions. All right, cool. Yeah, do you have some?
No,
Cool.
that's just good fire.
Well, then, with that being the case, I think I'm going to go ahead and wrap this up. I'll just go ahead and say, if you're ever in Atlanta, come by ATL BitLab. Let us know if you want to work out of the space and try it out. We have membership options for anybody who needs a place to co-work. And we have several, 2 Freedom Tech events usually most weeks. Every Wednesday night is Bitcoin night. And yeah, don't forget, if you're interested in the hackathon, just join the Discord. We'll help you with your project, help you find a team, all that stuff. So thanks for tuning in, and we'll catch you on the next one.